Today in this video lecture we will see SFD BMD of this beam. We will see shear force and bending moment diagram of this simply supported beam with 5 kN concentrated point load at its middle. We will see this beam thoroughly. We will solve this theoretically. We will see the shear force and bending moment diagram in ETAP software also, and I will tell you thumb rule also for this shear force and bending moment diagram. First, this is beam. Now, first step is draw free body diagram of this beam. Free body diagram, that means we need to remove support. See how I remove support. Here pin support, that means there are two reaction occurs. One is this and one is this. Here roller support, that means only vertical reaction. This 5 kilonewton load is as it is at a distance 5 meter, and this is 10 meter length beam. So let us consider this as a point, this as a B point, and this as a C point of this beam. Now we need to calculate first reactions of this beam. This vertical reactions is AY, horizontal reaction is AX, this is CY. So calculate reactions of this beam. First, summation of forces in x direction is equal to 0. Forces in x direction, there is only one force in x direction, x is equal to 0. Why ax is equal to 0? Because no other force acts in x direction, so only ax is equal to 0. There is no counterbalance for this ax. Now see, for ay and cy, summation of forces in y direction is equal to 0. Upward forces positive, downward forces negative. Here right hand side forces positive and left side forces negative. Ay plus cy minus 5, this ay, this cy, and this is minus 5. That means ay plus cy equal to 0. So we need to calculate one of them, ay or cy. If we take moment at C, that means this 5 kilonewton and this ay comes, and if you take moment at A, this cy and 5 comes. That means take anywhere. I take moment at A, summation of moment at A equal to 0. See, clockwise moment is positive and anti-clockwise moment is negative. Take moment here at this point. See, this 5 kilonewton force is clockwise through this point, clockwise, and this cy is anti-clockwise first, and this ax goes through this point. That means this we not consider in moment calculation. This ay is also goes through this a point, though ay and ax we will not consider in moment calculation at point A moment. So clockwise, that means positive 5 into this is vertical downward force. This force multiplied by perpendicular distance to that force up to that point. See, this is force and this is perpendicular distance through point A to that force. So 5 into 5 positive. 5. This CY, see this CY, CY is anti-clockwise. So anti-clockwise, that means minus CY into distance between A and that C point, perpendicular distance to that force, is 10 meter. So CY is equal to 2.5 kilonewton. Ax is equal to 0. Now put this CY in equation 1. CY is 2.5 kilonewton. That means AY plus 2.5 equal to 0. That means this AY is AY plus CY 2.5 equal to 0. That means AY is minus 2.5 kilonewton. And firstly, we assume our AY direction is upward. So this value comes negative. That means this AY direction is actually downward. See this AY. AY is actually downward. And CY is upward. Direction of force. Now we need to calculate shear force and bending moment. So we will see this thoroughly. For that, I will take section. Take section XX here, X. So just for your understanding purpose, I take this section. See how is this section, and your choice. You may take right hand side or left hand side. Right hand side section, see there are less forces, so calculation is easy. Sorry, here left right. See right side, there are 5 kilonewtons CY, and left side only AY, AX, and AX is 0. That's why I take left hand side section. Left hand side of this section. So AY is this minus 2.5 kilonewton, and this AX is 0. That's why no need to write, and we need to draw here shear. So see, this is positive shear and positive movement. So we cut here from left side towards right side we go. So from left sides toward right sides. So this is positive. So draw here Vx and Mx. If I take this section, this, for your understanding purpose, I write this section also only for understanding purpose. See, this is CY, this is somewhere at middle 5 kilonewton, and here C from right to left, this shear force, and like this. So now calculate this Vx and Mx. We don't know distance, so let's assume this as a x distance, and shear, and we need to calculate this Vx. So this upward positive, that means 2.5 kilonewton, that when value is negative, so minus 2.5 and minus Vx is equal to 0. So this Vx is 2.5 kilonewton, and this x is greater than 0, and see, this x is greater than 0 to less than 5, because section is similar throughout. There is no in between load between 0 to 5. So 0 to 5. Now next is moment calculation for that section x6. Consider clockwise movement positive and anti-clockwise movement negative. So here, and we take movement here at this point. So this clockwise minus 2.5 into x, and this is anti-clockwise minus mx equal to 0. So mx is equal to minus 2.5 x, and this x is also in between 0 to 5. So moment at 0 is equal to 0 kilonewton meter, and moment at 5 is equal to minus 2.5 into 5 kilonewton meter. So 5 into minus 2.5. So put in your calci, 5 into minus 2.5 is, and unit is always kilonewton meter, minus 12.5. See sign also. It means here minus 2.5 comes. Why this minus comes? See, positive. That means AY is positive, minus 2.5, and this is also anti-clockwise, clockwise, anti-clockwise. Okay. Now next is take section YY here. Where to take sections between this AB and between this BC. So see, for this YY section, this right side is simple, only one load. This left side is there are too many loads. So I select this right side, CCY, section YY. This is CY and this point. So our this is positive shear and this is positive movement. So from right to left, this terminology comes. This is upward shear and this is movement. This is Vy and this is My. Let's assume it. And in between no load. And this Cy is 2.5 kilonewton. So take shear. So shear is plus Vy plus Cy. Upward forces are positive and downward forces are negative. Plus Cy plus Vy equal to 0. So Cy is 2.5 kilonewton plus Vy equal to 0. This is lengthy procedure. Only for your understanding purpose, this procedure understanding is important. Vy is equal to minus 2.5 kilonewton. So shear is minus 2.5 here also. And here see, shear is positive 2.5 and here minus 2.5. And movement is, that means this is at a x is between 5 to 10, because see, we take section, where we take section yy section, here between 5 to 10 there is similar section, no loading. And movement is, I will tell you also simple thumb rule for calculation of this movement and shear. No need to calculate this like this method, this is only for understanding purpose. So movement, we take movement here at this point. So clockwise movement is positive, anti-clockwise movement is negative. So this is, see, this force goes through that point where we take movement like this, and this is anti-clockwise rotation. So anti-clockwise is minus Cy into, so this 2.5 minus Cy into x. We don't know this distance, so put it as x1 minus Cy into x1, and this, see, this clockwise movement plus My. See here sign changes, My sign changes, plus clockwise. See, this is plus and here this is minus because anti-clockwise. So Cy is 2.5 kilonewton minus 2.5 x1 plus My equal to 0. So My is equal to 2.5 x1, and this x1 is 5, m5, 2.5 into 5 is 7.5 kilonewton meter, and at 10, movement at 10 is equal to, see, something is wrong here, minus Cy into, no 10, it is 5 only, it is 0 or 5. See here, this is 0. Don't remember, don't go like this for, see here, x for x, this is not 5 to 10, this is 0 to 5, and this is from right, 0 to 5 from right to left. So at 0 there is 0, m0 0 kilonewton meter, and at 5 there is 2.5 into 5, that means 12.5 kilonewton meter. And see here is minus 12.5 kilonewton and here is 12 plus 0.5 kilonewton, that means something is wrong here. Since AY is, we need to calculate this AY again. AY plus CY minus pi. See, we don't write here minus pi. So that's why this mistake occurs. Minus pi equal to 0. So AY our numerical is correct, only AY plus CY minus pi, and CY is 2.5 minus pi equal to 0. That means AY minus 2.5, that means this is positive 2.5 kilonewton. That's why. See how mistake happens. Mistake, remember this mistakes also. This is upward direction. So that's why our assumed direction is correct. So now this is also clockwise. So see here clockwise, positive also, here also positive, positive, EMX positive. So this is also 12.5 kilonewton meter. So we need to draw SMD BMD as per our calculations. So don't make mistakes in mathematical calculation. See how mistakes happens. One mathematical mistake, all SMD BMD was wrong. So this is our 5 kilonewton. 5 kilonewton. Total length of this beam is 10 meter, and this is also 5 meter. This is also 5 meter. So see here CY, there is 2.5 kilonewton reaction. We need to draw it neat. This is AY, this is CY, and this is 5 kilonewton. So see our AY is 2.5 kilonewton, and at 2.5 distance, at 0, Vx is 0, and at, see here, V at 0, 0 kilonewton. No, V at 0 is also 2.5 because this value is constant. Shear at 0 is also 2.5 kilonewton because here there is no x in equation, and shear at 5 is also 2.5 kilonewton. And so draw here 2.5 kilonewton and no change. So here also linear line, constant horizontal line 2.5 kilonewton. And see, with the help of equation, here shear V at 0 from left, V at 0 from left is minus 2.5 kilonewton, V at 0 from, V at 5 from left is minus 2.5 kilonewton. So here there is sudden drop. Minus 2.5 kilonewton. This is positive, this is negative. Now draw bending moment diagram also. See this moment This moment at A is AY. At pi it is 12.5 kilonewton meter, and at 0 it is 0. See, moment at 0 is 0 kilonewton meter and moment at pi is 12.5 kilonewton meter. Moment at 0 is 0 and moment at pi is 12.5 kilonewton meter. And moment at 0 from right is 0 and 0 from 5 from right is 12.5. That means similar. So this is 12.5 kilonewton meter positive. So this is our shear force diagram and bending moment diagram. So this is very lengthy process. So see short method of this SFD BMD calculation. See similar beam. This is AY, this is CY, and this is 5 kilonewton at middle, and this beam is 10 meter beam. So see this 5 kilonewton is at middle. That means every action there is equal and opposite reaction. That means this AY and CY take half of this. So reaction comes 5 half, that means 2.5 kilonewton. 2.5 kilonewton and here 2.5 kilonewton, and this is 5 kilonewton as it is. And now shear force diagram. See this 2.5 kilonewton is upward, that means this is upward. There is no load in between, that means there is horizontal line. See this 2.5 kilonewton, there is sudden drop in load 5 kilonewton, that means 2.5 minus 5 minus, because there is downward direction force minus 5 kilonewton downward direction. That means minus, and 5 kilonewton is 5. 2.5 minus 5 is minus 2.5. So minus 2.5, here there is also no load, so horizontal line and upward 2.5. Minus 2.5 plus 2.5, that means here 0. So this is positive and this is negative. And now for bending moment calculation, where there is shear force 0, see here shear force is 0, that means there bending moment is maximum. And here no load, that means inclined line in bending moment calculation. So here inclined line, here maximum where shear force is 0, and here also inclined line, and here 0 because there is hinge support and roller support. In hinge support and roller support there is no reaction. And value, how to know value? See, this is 2.5 and we need to take movement here at this point. We consider clockwise positive, so, and this distance is 5 meters, so 2.5 into 5, 2.5 into 5, that means this 12.5. See, consider from here like this clockwise, or from here also anti-clockwise. In anti-clockwise we need to consider sign appropriately. So 2.5 into 5 is 12.5. Positive. So now this is our theoretical method. Now we will see this beam SFD BMD in ETAP software also. So see, this is ETAPS 2022. This is model initialization. Click user built-in setting, display unit metric SI, region for default material India, steel section database Indian, steel design code IS 800 and concrete design code IS 456. Here blank. See this ribbon tab of this ETAP software and tools of this ETAP software. This is specially for building analysis software. In building design we use it. So our objective is to calculate SFD and BMD here in ETAP software. For this, define material in material properties. Define material property GM30, modify show property. So this is GM30 concrete. Okay. We calculate BMD for live load only. This 5 kN is live load. So here we don't consider dead load of this beam. So, but here for error purpose we provide section also. Here beam for SMD BMD calculation. Take it as it is 0. Okay, here select beam, here bottom select SMD BMD. Now our beam is 10 meter, so this is 10 meter. Select this beam, go to assign joint, restrain in XYZ direction. Our beam is, see, our beam is 2 dB and it is restrained in here at point A in X and Y direction, but here restrain in XYZ. So restrain, select point, this is our A point, select, and this is C point also CY restrain. So restrain it in like this in XYZ. So select beam, go to assign, go to frame loads. Our load is point load. Click here absolute distance. Our beam is 10 meter and at 2.5 meter, at 5 meter load is 5 kN. So, and here select live load. We need to check bending moment for live load calculation. So run this, save. Analyzing this, please wait. So recheck this manually and in software also. What is difference? Go here, display frame, spear pendles, movement 3 for live load. Apply. Okay. See here also movement 3 for live load. Apply. Okay. See this movement comes. See shear 2.5 kN here. Here shear 2.5 kN. Our shear is also 2.5 kN. See ETAP software sign convention. This is from start it is negative 2.5 and at the end it is positive 2.5. Our is, so sign convention is different while calculating. And here bending moment is also 12.5 kN meter. Here ETAP software also gives us deflection 0.974 mm. So shear is 2.5 kN as per software and our manually calculated shear is also 2.5 kN. Shear is 12.5 kN meter maximum shear as per software, and our calculated shear is also 12.5 kilonewton per meter. So this is how we calculate shear force bending moment diagram in software and in manually also. So thank you very much. So this is how we calculated bending moment and shear force diagram in software and in manually also. See, this only this portion is in negative. This is in negative. Due to change in sign convention, there is difference. But shear value is magnitude is similar 2.5 kilonewton, and bending moment magnitude is also similar 12.5 kilonewton meter. So see here, bending moment is positive. Bending moment is not negative. Bending moment positive, that means correct. Only they shown it in downward. In ETAP software they shown it in downward. Only here shear they take from 0 to 5, it is downward minus 2.5, and 5 to 10 it is positive 2.5. Due to difference in sign convention, I think they consider upward as negative, that's why they take it. So this way our SFD BMD completes. Thank you very much.